Right, we go back onto our unfinished chapters. We are at the template literals string. Right, so let me take this out here and we do Notion. I'm going to take a few notes and then, yep. JavaScript bootcamps. Okay.
We can remove every double quote that we have and then wrap around the string that we want to create these backticks. We've seen how to create $ and curly brace syntax, just like this. And when we do this and run our code, we see our greeting, we get the same result, but in a far more straightforward, convenient, and readable syntax. And one more essential thing to note about the template literal is that the $ and curly brace syntax that we used can resolve many valid JavaScript expressions and insert them into strings. This is called string interpolation, as I mentioned, so if you put even a dynamically computed value inside $ and curly braces, it's first converted to a string and inserted into the larger string that's returned by the literal. So say, for example, we had our user's weight. We had it in a variable called weight. Say it was 150. And we wanted to show the person's weight on the moon. Well, we could take that weight and use a $ and curly brace syntax to perform the calculation inline. So say we had a variable called moon weight. And in it, we stored the string to show to our users, you weigh so many pounds on the moon. So how would we calculate the number of pounds here? Well, to evaluate a JavaScript expression here, we could just use $ and curly braces, and then we could take the weight and perform whatever calculation that we needed to get this moon weight value. So we could say weight times 0.165. That's a calculation to get the number to convert pounds on Earth to pounds on the moon. And when we do that, if we console log the result of moon weight, we see that you weigh 24.75 pounds on the moon. And note that this feature will be very helpful in later parts of the course, specifically when we build our apps, where we'll see how to put conditions in our template literals to conditionally show one or another elements to our app user. So as we see, template literals allow us to create much more powerful and dynamic strings, but in addition to that, template literals help us solve a few of the pitfalls that are present in normal strings created with single and double quotes. Let's take a look at a couple of those examples. And to see this, let's first ask the question, what happens if you try to use apostrophes or single quotes within a string created with single quotes? Let's say we had the text, I'm a string. We see that there's a problem here with this red squiggly line underneath our created string. And what about for double quotes? What if you tried to use double quotes in a string made with double quotes? Naturally, we see that both of these strings are broken, but there's a quick fix. We can recreate both of these strings with the other type of quote. For a string made out of single quotes that has to include a single quote, we can change it by wrapping it in double quotes And for a string that is made with double quotes that needs to include them, we can wrap them in single quotes. So now our two strings are fixed. Or another approach would be to tell JavaScript that it should ignore the characters within our strings, to basically say we're not creating a nested string here. We can do that with a backward slash. So we can use a backward slash, or what's known as escape, each of these quote characters. And once again, we have two valid strings. Note that the backward slash isn't going to be included in our final string. So these two techniques are important to know, but if you always want to avoid this issue, you can simply use template literals.
Yeah,
now,
that
no
is
such
like
issue if you want to use quotes of any sort in your
confusing way
strings.
of doing this.
Now here's
Just
another
need to do
question.
template
What if you
string.
want your text to span multiple
Use-
lines? So let's create a variable called 3 lines with some text. Say this is a string that spans across 3 lines. How do we get this string to actually go across 3 separate lines? To do that, you have to use a couple more special characters. You have to use the new line character, which is a backward slash and then an N. And right here, where we include this character, we're going to introduce a line break into the string. And another approach to doing the same thing is to use the backward slash R syntax, which is called a carriage return. It basically does just the same thing. So now we have 3 lines for our string here, and this works, but if you had more text, you can imagine how annoying it would be to have to keep writing these new characters for each new line that you wanted to create. In order to make our code more readable, we can instead use, you guessed it, template literal strings. These eliminate the need for concatenation or escaping on long strings that contain new lines. So we can just replace our string with template literals, we can remove the new line return, and we can just add returns ourselves wherever we want the line break to be. And wherever we put them, these new lines will be preserved, just like we wrote it. So note that we'll still be using single and double quotes for basic strings throughout our code, but remember that if you want to manipulate your strings in any way or escape some of the common pitfalls when using single and double quote strings, template literals are the best choice.
Use this and then the variables name in to refer to the variable value in template string. Right.
We've seen how to create text in JavaScript using strings, and they can be made either with single quotes.
Alright, it's time for a coding challenge about template literals. So, here is the challenge. We're going to help Darth Vader express himself to his son. We have a const called mySon, which has the value of Luke, a const of parental status that has the value of father, and a const message, which is what Darth Vader wants to say. He wants to say, Luke, I am your father. However, and then use these 2 variables in order to create the sentence, using them here and there. But when we're logging it out, we're getting my son, I am your parental status, which obviously isn't what we want. So how do you change this string right here so that JavaScript manages to interpret these 2 words as variables and not as just the strings themselves? As always, if you need help, check out the hint section or rewatch Reed's tutorial.
Right.
So go ahead.
What we are going to do on this is pretty easy. Just need to change this from here, from this to this. And now we have what we call a template string. And then we wrap it inside a open a dollar sign and opening and closing curly braces. Now we have Luke, I am your parental status, right? We run this, Luke and parental status, and we do the same things on this with parental status. Now we run, Luke, I'm your father. Okay.
Go ahead and solve it right now. Let's see. Luke, I am your parental status. Okay, let's then do the same thing with great job if you managed to do that. Let's move on.
Move on. How variables should be named. How to name variables. Variables.
Now we're going to talk more specifically about how JavaScript variables should be named in your applications, both what the language doesn't allow you to do and how you should name variables so you and other developers can easily know what values they contain. Let's start with a question. I'll create 3 variables with the identifier name, but they're all going to be written a little bit differently. The first one is going to be in lowercase, the second one I'll capitalize, and the third one with all caps.
All caps and...
So my question to you is, are these the same variable? What do you think? When I run this code, or say console log them, will I get an error?
No.
When we log them, we see that they're all separate, valid values. In other words, the variables were created successfully. So from this example, we can see first of all that variables are case sensitive. They can have the same identifier, but with a different casing. So casing matters. Second, variable names should be clear about what data they contain. So let's say we're looking at someone else's code and we see this.
That's not good as well.
My question is, do you know what's taking place?
No capital.
If we look at the code, we see that 2 values are being concatenated. So we have a sense of what we're going to get here. We're going to have an end result of a string being put in new value. But you have no idea what these values are, and only a general sense of what data type they might be. Now let's improve the names of these variables that we're using.
First value, first name, whatever.
What do you think? Can we see and understand exactly what's going on here? Yes, we can infer from these names, first name and last name, that they're strings, and that full name will be a string as well. So variable identifiers should be self-descriptive, and they shouldn't require comments for others to know what they hold. And third, variables should in most cases be written in camel case syntax, as we see here, where the first word in the name is lowercase and the rest, any words that follow it, should be uppercase. So let's just do a quick quiz. Which of these are correctly written in camel case?
Last one.
Just the last one. The camel case convention is the most important rule to remember when writing JavaScript variables, but there are other helpful conventions, meaning ones that are helpful to follow because of what they signal to other developers, but they aren't required by the language itself. Since JavaScript is a loosely typed language, meaning any variable can contain any data type, the way that we name variables can tell other developers what type of data it should hold and does hold. Let's say we are controlling in our application whether a modal or a pop-up is visible with a given variable. If a variable is true, the modal is visible. If not, the modal is not going to be shown. To tell other developers exactly what this does, we could have a variable called isModal_visible. So why prefix this with is? Well, not only does it tell us with this prefix that it contains a Boolean, either true or false, but it's easy to read in conditionals. To see an example of this, if we wanted to do something, if the modal was visible, if isModal_visible was set to true, our code would be the following. If isModal_visible, do something. Now, due to our naming here, our naming convention, this conditional reads just like a sentence. If the modal's visible, do something. The closer that we can get our code to reading like it was just plain instructions to other users, the better. And now, to figure out the prefix that these variables should have that contain Booleans, put the variable in a conditional and read what it says. Usually variables that hold Booleans are prefixed with is or has. For example, we might have some variables like is loading. This is a very common one. Or another one, has position, etc. And another valuable convention is for variables whose values should never change. We already know that we have the const keyword to create variables that can never be reassigned. However, for variables whose value should never be changed by other developers manually either, we write the variable names in all caps. So to give you an example of this, we might have in our application a specific color red, a hex code with a value of red that's saved in a variable so we can easily reference it throughout our application. And in this case, the hex code itself is never going to change. Therefore, it doesn't need to be updated by anyone. And to tell others that, we can use all caps for its identifier. We can say const color red is equal to the string, the hex code F00. And note that unlike camel case, when we have a const variable that shouldn't change, in addition to making it all caps, we separate words in the identifier with underscores. So let's do a quick recap. First of all, variables are case sensitive. Casing matters. Their names should be self-descriptive. We should know exactly what a variable holds based on its name, and from that have an idea about what data type the variable should hold and does hold. And most every JavaScript variable you write will be in camel case. However, since variables can hold anything and can be changed easily, we use conventions to give more information to other developers, like using is or has to prefix variables that hold Booleans, and using all caps for variables that hold values that should never change, that a developer should never manually change.
I see. Module intro, type and condition.
In this section, we're going to talk about types and conditionals. We're going to talk about the most basic conditionals. And to start things off, we'll begin with how we can conditionally run code in our JavaScript with the help of if statements. Then we're going to touch on the different types of data in JavaScript. Up until this point, we've covered strings, numbers, and Booleans, but now we're going to take a look ahead and see all of the types within the language, as well as how we can change types and how we can change one type of data to another type of data in JavaScript. Then we're going to see how we can make even shorter conditionals with the help of a feature called a ternary statement. And then finally, how to use some special operators called the and or operators to make our conditionals even shorter, even more succinct. Knowing data types is going to give us a better handle on how data in JavaScript behaves, and conditionals are a core part of working with JavaScript and determining whether one thing happens in our application versus another. In other words, they're both crucial to making reliable JavaScript applications. So let's get started with types and conditionals.
Conditional.
In our applications, we need to have the ability to do things based off of different conditions. This idea of doing things in our apps conditionally is a core topic that's glossed over too often. It's crucial to be able to write conditional logic within our applications effectively and clearly. It has the ability to make our code significantly clearer, more reliable, and less bug prone, all at the same time. So we're going to start off with the most essential and familiar type of flow control in JavaScript apps, the if statement. If statements evaluate Boolean values, which means whether something is the value true or not, which is a Boolean. So a common trend now is to create a dark version of applications for our users. So let's say we're in the process of making this dark alternative for our app, and we want to store our user's color preference in a variable. Let's say the variable prefers dark mode. And this variable will hold a Boolean value. That's either true, if the user prefers dark mode, or false. They want the normal or light version. So how do we write a basic condition to flip our app to dark mode if this value is true? The basic syntax of if statements is to use the if keyword, then evaluate the Boolean within a set of parentheses. If JavaScript assesses this value to be the Boolean true, in this case prefers dark mode, we run some code within a set of curly braces, where in this case we could simply console log dark mode set. Or if we actually want to change the screen to dark, let's open our mini browser. If we actually wanted to change the screen here to dark, we could actually do so with the following line of code. Note that you shouldn't worry if you don't understand this particular line. You will later on in the DOM section. And then alternatively, we can specify what should happen if the user doesn't prefer dark mode, if that value is false. So let's see if we could add this functionality to show the light mode if they don't prefer dark mode. We could try adding the code to do so underneath our if statement. We could log maybe light mode set in that case, and we could set our app color to another valid CSS color like ghost white. So at the moment, the user prefers dark mode, and if we run this code, we see that it no longer works. We see light mode set. The reason for this is that we're running our if statement and setting the background to black, but our program doesn't stop there, and the code afterwards is setting it to the light version. So how can we only set it to the light version when prefers dark mode is false?
Also,
This is where the else keyword comes in.
Else.
To make sure code
Also.
runs only if a condition is not met, we pair an if statement with an else statement immediately afterwards. To do that, we just write the else keyword afterwards, and then another set of curly braces for the code to run in any other case provided the if condition is not met. Drag in our code into this else condition. So now, if we run our code again when the user prefers dark mode, we're only then setting the app to the dark mode, but if prefers dark mode is now set to false, we see that our light mode is set. Now what if we had multiple conditions? What if, for example, we had a solarized version of our app? This is an alternative to the dark mode, which set the background color to a pale yellow color. So based off of what you now know, see if you can write an additional condition to our if-else that will enable us to, if a user prefers solarized mode, actually show within our browser that solarized mode. And if you can't come up with an answer, that's fine. Just think this through and figure out what needs to happen. What needs to happen is that we need to find a way
So we need to do solarize.
to add another if condition after our first one. So this needs to be after our first if condition, but before our else condition. And we can do this by using the keyword else if. So else if is placed after the if but before the else, and it accepts another condition between a set of parentheses. And in this case, if we have a solarized version of our app, this condition might be based on a new variable that we could create called prefers solarized mode. And let's initialize that to true. And now we can log the mode that we're setting if the user prefers solarized mode. So we could say, in this case, solarized mode set, and we could set the actual background color to, let's say, pale goldenrod. And if we run this, we see it's set to that solarized background. So why, when we ran this code, did the else condition not run? The reason for this is that else if is basically behind the scenes the same as just an if statement. So since our condition matched and ran the code to make our app solarized here, since prefers solarized mode was true, the else part didn't run. And finally, let me make one small change to our code here. Let's say that our user prefers both dark mode and solarized mode. Both of these values are set to true. What's going to happen when we run this code? We're going to see that our dark mode's set. Why? Because if-else statements and basically all conditionals in JavaScript, with some exceptions that we'll mention, work according to what condition is met first. Since the condition for prefers dark mode being true was matched first, the condition ran the appropriate code for that condition, and then JavaScript finished running the conditional. Now, based off of this bit of information, how could, without modifying our variables, we get the app to display our solarized version? We don't want to change these variables, but we want to do something to our conditional to show our solarized mode. See if you can implement the solution yourself. All we have to do is swap the order of the conditions. We can make else if appear earlier within our code as the if statement up at the top, and then we can make the what was previously the if statement appear as the else if. So now the prefers solarized mode condition is being satisfied first. Now on top of the if else, there's another pattern for flow control in JavaScript. To see its benefits, let's modify our if else statement a bit. Let's say that instead of having these variables prefers dark mode or prefers solarized mode, which hold Boolean values, we had a single variable which held a string value. Let's replace it with these two variables with a single variable which we'll call color mode. So instead of having it store a Boolean, it would hold, say, the value dark or solarized or light. So how would we rewrite our conditional now to dynamically change the colors? What we'd have to do is provide comparisons to each of these values. Since our if or else if expects a Boolean, we would have to use the triple equals within each condition to see if the mode was the string solarized, and we'd be comparing with color mode. And then for the else if, we would check to see if the color mode was string dark, etc. So try to imagine we had a lot of possible color modes. Think of how tedious it would be to have to write each of these comparisons to a given string. It would be hard to write all of this out. It would involve a lot of repetition, plus this isn't very easy to read. A better way to write this logic is with a switch statement. Why? Because our conditions don't have to use Boolean values for switch statements, and the switch statement performs such comparisons for us automatically. It's really ideal for any type of flow control where we have lots of different conditions. So to rewrite an if-else to a switch, we can first replace the if keyword with switch, and we don't have to write any of these comparisons anymore. We can just pass in the value to the rest of the conditional. We can pass to switch color mode. And now to run some code based on the color mode that the switch statement is evaluating, we don't have to write else if or parentheses and curly braces and a comparison. So let's just comment all of this out. What our switch statement will have, however, is a set of curly braces around it. We just have to turn each of these conditions into an individual, what's known as a case. So the case that the color mode is equal to solarized, then after it we include a colon, and after this we can write our related code. So we can copy our 2 lines, or uncomment our 2 lines here. So this is the code that will be run when color mode is solarized. And note that our code that we want to run for a certain case should be indented slightly, as you see here. So we want to write individual cases for each of our if statements that we have here. So see if you can take our previous conditions that are commented out and turn them into cases in our switch statement.
Alright, so we do switch, we do case, then we do doc, doc, right? Then we do this, and we copy the same things right here. Right. Run. It's black, right? So what we can do here in additional to if, else, if, and else statements. We can use switch and case for it as well.
So again, we just have to create a case, but the question is, how do we rewrite the else condition? We do so using a special keyword within switch called the default keyword. So if no cases match, if neither of these cases match, the default cases run. And again, we need to include a colon after it, and then we can provide the else code, the code that we had for our else condition. And if we run this code with the color mode of dark, we see that we have dark mode set and then light mode set. So what's going on here? Well, first we're having the case with the string dark match our color mode, which is what we'd expect, but it's continuing on to our default case. So what needs to happen? Well, within a switch statement, in order to tell it that we just want it to apply to a single case, we need to include, after our code, the break keyword. So after the case dark matches and we run this related code, we want to break, and this is going to prevent any other case or our default case from running. So now if we run this,
to prevent default from running after case is satisfied. After case is satisfied, use break at the end of case statements. Let me slap this mosquito.
we see that only dark mode is set. So we want to apply the break keyword for our solarized case as well. So in this video, we got a taste of the two most essential flow control structures in JavaScript, as well as when they should be used, what they offer as compared to one another, and we're going to become very adept at using them throughout this course. And if we run this, JavaScript finished running the conditional. Now, based off of this bit of information, how could, without modifying our variables, we get the app to display our solarized version? We don't want to change these.
So it's set to dark, and then we change it. Mosquito, mosquito, mosquito. Guys, it's raining season over here. Mosquito are freaking annoying.
Video, we got a taste of the two most essential flow control structures in JavaScript, as well as when they should be used, what they offer as compared to one another, and we're going to become very adept at using them throughout this course.
Alright, it's time for you to put your skills to the test. You're going to write your first conditional. So here is your challenge. You're going to create a conditional that logs out either good morning, good evening, and so on, depending on the value of the variable time, which you can see down here. It can take the value.
Let me check something.
value morning, afternoon, evening, and night. And secondly, you're also going to rewrite the whole thing as a switch statement. And as always, if you need help, you can check out the hint.js section or revisit Reed's screencast. So go ahead and solve this challenge right now.
Create a conditional as log out morning, good afternoon, so on. Depends on const time, so could be afternoon, evening, night. So we should do a switch. However, case is going to be morning. Is it? Do we have to put it in here? Right, let's watch the screencast again.
In our application, see if the mode was
Not this. Here, solar rays. So we need to put it into. Right, let's copy this. Put it in here. Call this code. Inspect, paste. No. Right here, this is good. Put it in here. Boop, 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 boop. Alright, and we do closing brackets. Closing brackets. Alright. So here we'll do morning. Then this columns. And then we do another case where it is going to be afternoon. Alright, and then we do the other one is going to be case. Night. Here is going to be console log, and console log. Console.log. Afternoon. Right. And so on, depends on the value of time, a variable. Alright, we run this. We might. So we need to break. So default is going to be good morning. We want default. Yeah, let's do default. We do break. Run. Why is it? Default, there's no value. Good morning. Right. We open the console up. Right, that's good. Now we copy the same things. So we do const time if time equal then console log this, that's else if time equal, here is going to be afternoon, then we do this, console log good afternoon, then we do another else if evening, here, yep. Then we do else, console log good night, run. Assignment to constant variable. Let's, right, good morning twice. Now let's do this to afternoon, run, it's still good morning, else if time equal, else if time, why is it, maybe it's taking here. Right, let's turn this off. Good morning. Night. Good morning. Right, this close. This is close. This is close. And this is close.
Time else
Equal. Since same type and same value. Right, run, good night. The other one is like just the same. But why is it not working? This one is same type. Right? Still the same. But when we do equal to morning,
we're just going to copy this like that. And the first condition, time triple equals to morning. And then, instead of curly brackets,
equal, and same value and same type, if I remember. I see.
Inside the body of these curly brackets, we write what we want to do. And in case of morning, we're going to console log good morning parentheses. That is keyword. We also want to congrats, and let's move on with the course.
Let's start with a quick overview of JavaScript types, the different data types that we can use within the language. There are two kinds of data types in JavaScript: primitive types and object types. And primitive types are the following: string, number, boolean, undefined, null, and symbol. And everything else that's not a primitive is an object type. As we saw earlier, JavaScript variables can hold any type of data. Another way of saying this is that JavaScript is loosely typed. So we have data types in JavaScript, and variables hold on to whatever we give them, whatever we assign to them. But then how do we figure out what the data type that a variable holding is? Well, we get the data type of a variable through the type of operator. So let's say we have a variable called message, and it's holding on to some string. Using the type of operator, we can use type of directly on message, and if we console log the result of this expression, type of tells us that message is holding on to a string. And note that type of gives us an answer as a string. But we don't have to get or create a variable in order to use type of more values, say different types are in JavaScript, as well as how to get them whenever we need them. But what's very important in JavaScript is how one type of data is converted to another. We have to be familiar with how JavaScript converts data and how a piece of data is changed from one type to another to be able to prevent potential errors in our program or unexpected behavior of any sort. So yes, let's be clear that you can convert one data type to another in JavaScript. And there's two ways that we can do that. Number one, the first approach is explicit type conversion.
Right, well, so we do type. Oi. Type of variable. Type of variable is a type of variable type. Variables types. So we do this and heading one. Then we go here and we do primitive string, numbers, boolean, undefined, no, symbol. That's it. We call this heading 2, and everything else is going to be heading 2 object.
And this is through certain functions that are available everywhere in the language, such as the string function. And the second approach is implicit type conversion. We're not expressing that we want to convert one type to another. JavaScript just does this for us automatically. So this is also called automatic conversion. So let's take a look at explicit type conversion. For example, if we wanted to change some number to a string, say we wanted to turn 42 into a string, well, we could use the global function string to do that. If we log the result, we see 42 is now a string. And conversely, if we wanted to convert a string, such as the one in message, to something else, such as to a boolean, if we ran this code, we get the value true. So we can do these kind of weird explicit conversions where we could take a string and turn it to the value true. So as we can see, JavaScript always tries to convert one data type to another without throwing an error. So this is explicit conversion, where we're telling JavaScript that we want to change data types. However, for many operations, JavaScript automatically converts the data if the data types don't fit together for a certain operation. And this type of automatic conversion is called coercion. For example, certain features of the language will perform coercion. Say if we had the string 1 and the string 2 and we use the multiplication operator on them. What do you think we'd get if we console log this operation?
We get numbers, not a string.
Well, we actually get a valid number of 2. So how could this be? We're multiplying a string by a string. This isn't a valid math operation. Well, what's happening is that the multiplication operator coerces the string 1 to the number 1 and the string 2 to the number 2. So this is a very clear case where we're not telling JavaScript that we want to change these types to another. It automatically does so. It coerces our types to make this operation work, so it doesn't have to throw an error. So let's take another example. Let's try mixing two different types together, a string and a number. So let's take the string 10 and see if we can add it to the number 20. What do you think? Will this work?
1020. It's going to be 20.
Yes, in fact it does, but this time we get the string 1020. So as you can see here, when values of two different data types are combined in JavaScript, one wins, so to speak. We're adding a string and a number, and the result was a string. We got a taste of this in the last video where we saw that we could concatenate strings with the plus operator. So now we're going to dive deeper into coercion and how it can affect our programs. But first I want to give you a short lesson about types, and it's probably the only time in the course I want to tell you to commit something to memory. It's not much to remember, and it's going to serve you well in your JavaScript career. You'll be more familiar with this as time goes on. You can always look this information up, but the sooner you memorize what I'm about to tell you, the better. This implicit coercion that we just saw takes place for any conditional that we write. So any value being evaluated within a conditional, meaning the parentheses of an if statement, or say it's an else if, or a switch statement, or a ternary, as we'll cover later, JavaScript is going to automatically try to convert what we pass to its parentheses as the condition. It's going to try to automatically convert this to a Boolean. So what's important here is that any value we provide to a conditional doesn't have to be a Boolean. There's a more predictable outcome when we use Booleans and conditionals, so we can easily check to see if something is true or false. This allows us to more easily reason about what should be the outcome, but it may not be a Boolean for one reason or another that we're passing in here. It might be a string. We might be using our message variable. It could be a string, number, function, or really any other data type. So first let's take a step back and be clear about how conditionals work in JavaScript. Let's take a simple if conditional. If a value is true, then we want to do something with that value in this then area. If true, then do this. This looks simple enough, but we can make it even more clear as to what this actually does, what JavaScript actually does when it evaluates a conditional. And this applies to all conditionals as well. In conditionals, JavaScript tries to convert the value, regardless of what data type it is, to a Boolean, and then compares that value with true. So it really looks like this. We use the Boolean function, we pass it the value, and then in this condition, JavaScript compares it with the Boolean true. So only if this expression evaluates to true, if true is equal to true at the end, then are we going to have our condition pass. But this is how JavaScript looks at this. So JavaScript is going to take any data type that we provide to a conditional and then turn it to either true or false. But the question is, how do we know which it's going to be? This leads us to two very important concepts when determining the outcome of any conditional in JavaScript: truthy and falsy. We can divide all data in JavaScript that's not a Boolean, either true or false, into one of these two categories, truthy or falsy. When a value is truthy, that means it'll be coerced to the Boolean true in a conditional. On the other hand, if a value is falsy, it'll be coerced to the Boolean false. But enough explaining, let's take a look at some examples. For example, a simple if-else, where we pass in to our condition a non-Boolean value, say the string hello. Based on what we know now about how conditionals work in JavaScript, when hello is coerced to a Boolean. If the Boolean's true, our condition will be met, and in this case we might want to console log the text run. Otherwise, if it's not met, if hello is coerced to false, our else condition will run, and let's say we'll show the text skipped. So before we run this code, before we run this conditional, what do you think the outcome is going to be? If we run this, we see the text run. So based off of what we already know, we only knew we'd see run if the condition evaluated to true. So hello was coerced to true by JavaScript, and according to our previous definition is a truthy value. Now what if we replace the string hello with a number, say the number 0? What will the outcome of the conditional be? And therefore, what do you think 0 is, either truthy or falsy?
Falsy.
Here we see the text skipped, meaning
Falsy.
0 was coerced to the Boolean false, which tells us that 0 is a falsy value, meaning it becomes false when coerced to a Boolean. So after running these two examples, you might be asking, how do we keep all of these values straight? If we don't pass a Boolean value to a conditional, how do we know what the outcome of the conditional will be before we actually run it? As JavaScript developers, do we have to run every single non-Boolean value through a conditional first to see whether it's truthy or falsy? No, in fact, to keep everything straight, you just have to remember 6 values, and those are false, 0, empty string, and this can be an empty string with single quotes, double quotes, or backticks, null, undefined, and not a number. These are all of our falsy values.
Right, falsy values. Falsy values. 2. Then we do this, and we do false, 0, nothing, empty string, null, undefined, and not the numbers.
Remember these and you'll keep everything straight. Why? Because as I mentioned, everything that's not falsy is truthy. The most important ones, the most important falsy values that you'll encounter the most are false, null, and undefined. False is obvious, but most of the time we're going to be checking for null or undefined. Remember that undefined was the default way of JavaScript telling us that we had an empty variable. So undefined is when JavaScript says that something's empty, and null is when developers want to tell other developers that something is empty. We use the value null. And be aware that truthy and falsy values can trip up even the most experienced developers. So how do we deal with them? How do we avoid running into issues with them and make sure our conditionals run as we expected when we, or if we happen to use them in conditional logic? Here are 3 tips to help you avoid problems or unexpected results when comparing JavaScript data and working with falsy values. The first tip is to avoid direct comparisons in conditionals. So say for example we have a user in our application and we want to see if their username is an empty string. So what we could do is, knowing that an empty string is a falsy value, we could in our conditional check to see if username is equal to false, and then we can console log maybe the text no user. But due to what we know now about how JavaScript coerces values provided or expressions provided to conditionals, we don't need to provide a comparison here. JavaScript is already going to try to coerce or take our value and see if it's true or false. So a better way to do this, to check to see if we don't have a username, if it's a falsy value, is we can say if not username using the logical not operator. And when we do that, we see the text no user. And this is going to work for any falsy value that we provide. So it could be, there could be a case where the username is null. That's also going to work, or undefined, etc. So no need for comparisons in our conditionals. The second tip, use the triple equals, which is also known as the strict equals operator. We want to use the strict equals operator for our comparisons when we need to make a direct comparison, because they don't allow type conversion. They don't change our types to make the comparison work. And this is as compared to the double equals operator, or the loose equality operator, which will convert types at times. We can see this if we had two variables, let's say, that held the value null and another held the value undefined. Say we were checking to see if a user variable, which has the value null, is the same as this username variable, or something like that. So if we needed to compare null and undefined with the loose equals, and if this comparison resolved to true, we might see the text equals, otherwise not equals. And we would expect to get the text not equals because we know null and undefined are their own distinct types in JavaScript. But when we run this code, we see that we have the text equals. So what's happening is that the loose equals operator is coercing these values so that they're viewed as having the same type. But this is as compared to the strict equals operator, which won't do that. So this is going to recognize them as different types. It's not going to coerce them, and we're going to see the appropriate text not equals. And then finally, we want to use or convert to real Boolean values where needed. And this is in some rare cases, or say for example, we're comparing two values that result in nan, or not a number. In this case, we would expect the two to be equal. So again, we can console log equal if that's the case, otherwise not equals. But we still see the text not equals. So to fix this, we need to explicitly convert nan to their appropriate Boolean value. And when we do this, we get the right answer, equal. So be aware of these 3 tips when it comes to working with falsy values. Make sure to commit these 6 falsy values to memory, and you're always going to have a clear idea of both the outcome of your conditionals as well as how to write them in a predictable and error-free way.
Right. We will